Can I find it?
Do you have it?
Yes. Hold on, pulling it up. Heck. Okay. Okay, yeah.
Okay. So we're doing the lesson 8 one, right?
Yep.
Okay, so did you get all of the answers? Because since it's the same questions as the homework?
You're talking about for the review?
Yeah.
Yeah, I mean, I was going through all of them. I didn't finish all of them, but
Yeah, me
it
neither.
was kind of the same thing. Like, I kind of went over, like, the ones that I knew I was having problems on.
Mm-hmm.
Like, is there a way to check your answers?
On this quiz?
Like, on, like, the homework,
on
like, the review.
I don't think so, but since the quiz is all the same questions, it should let us know what the answers are when we're done.
Okay.
Right here. I'm gonna move my laptop real quick over to a better spot.
Okay.
Okay, so are we ready to start?
Yeah.
Alright, so 1 and 2 is done. And then, number 3. Wait, for number 2, what's the part 2?
I don't think we don't have the part 2.
Okay, who's gonna say? I don't remember seeing that.
No, because
Alright,
the individual preparation and stuff, that was just, the review.
Mm-hmm. Okay, so number 3 is which of the following variables is categorical? Number of animals in the zoo, randomly selected brand of toothpaste, age and years of vehicles, or A and B. I think it's brand of toothpaste because isn't categorical like categories instead of numbers?
Yeah, exactly.
Yeah, okay.
Okay, so 4 is the mean IQ test score in the United States is 100. 20 randomly selected statistics students took an IQ test, and the mean of their score was 112. Which of the following statements is true?
Wouldn't it be 100 as a parameter? And, well, I forget what qualifies as a parameter.
I mean, that one, I think it has to do with, like, hold on.
Or yeah, I remember reading it. I'm gonna try and pull it up.
It's numerical something or other.
Okay, it says a parameter is a true, but usually unknown number that describes a population. A statistic is an estimate of a parameter obtained from a sample. So it would be 100 is a parameter and 112 is a statistic.
Yeah.
Okay. So number 5. Rotham City has 4 distinct neighborhoods. The property values are very similar within each neighborhood, but they vary considerably from neighborhood to neighborhood. One neighborhood has very low property values, and another has extremely high property values. Property taxes are usually roughly proportional to the property values. What type of samples should we collect to gauge the residents' responses to a proposed increased property tax?
So, that would.
I would say a stratified sample because
Like little groups.
yeah, it divides them into their own groups, but then takes a sample from each group.
Uh-oh. Yeah, hold on. There. Yeah, I agree.
Okay.
Because I think we even had questions about that, like the whole neighborhood thing. It's better to just blotch it and then just take one from each group.
Yeah.
So 6 is when designed experiments are conducted in public school systems, researchers typically choose a particular district and randomly select teachers of say fourth grade students in that district. The experiment is then conducted using all the students in the selected classes. Which type of sample scheme is implemented?
That sounds like it's well, let's see.
Hold on, let me read it. So, I mean,
would it be cluster?
I mean, they group it as in like, okay, there's out of all the things, I mean, we're gonna go with this district, and then we're gonna have like within this like branches off into teachers. So you're gonna pick one teacher, and then it branches off to this like, I don't know. Yeah, I think so. I mean, it doesn't seem like it's anything else.
Yeah, so we're gonna go with cluster?
Yeah.
Okay. Alright.
Wait, do we even have a voluntary response? That's not even like a sample.
Yeah, I was gonna say that's not even a thing.
I was like, I don't remember reading about that.
Yeah. So 7, at a school fundraiser, the name of every person who attended was entered into a drawing. At the end of the evening, 6 names were selected to receive door prizes. Which type of sampling scheme was implemented?
Would that just be systematic? Simple. Wait, is there simple random?
Yeah, it's simple random.
Yeah. It's just random out of the population.
Yep.
Okay, so 8 is a special interest groups is conducting a survey regarding wolves in Yellowstone National Park to adequately gauge opinions on both sides of the political spectrum. The researchers took the list of registered Democrats and they selected a simple random sample of 100 people. Then they took a list of registered Republicans and selected a random sample of 100 people. Which type of sampling scheme was implemented? So would that be either stratified or clustered?
It would be stratified because stratified says it divides data into similar groups, and then the samples are taken from those groups. And so since they were divided up into political parties, it would be stratified.
Yeah.
Okay. A survey was taken of purchases at the crossroads. Open the data file, crossroads purchase, and use this data to answer questions 9 through 11. So we have to open that.
Where are you opening at?
It's on the review page, where in the lesson.
Okay. Oh, here it is.
Oh man, I don't know if I remember.
Okay, surveys taken. Open the file, Excel, and use the data to answer the using software. Calculate the mean of these data. Wait, whoa. Which one are we doing?
Crossroads purchases.
Oh.
Trying to see if I can remember the easy way to find the mean.
Oh, I remember that we did that.
Mm-hmm. Okay, I got the mean for column B. Do you remember how to do it?
I don't.
So you go to the column that you're trying to find the data for, then you go down to the bottom to the next blank
Yeah.
segment, and you click on it. Then you go to formulas, then you go to more functions, then you go to statistical, and then you click on average.
I gotta enable edit. Okay, so formulas, more functions, statistical,
Mm-hmm.
and then average.
Yep.
So did you get 4.77?
Yep. 4.77.
One or how many?
Yeah, 4.771. Okay. Now we have to do standard deviation.
And so there's a formula for that.
There should be, yeah.
Yeah. Answer function. Nope, I didn't do it right.
I got 1.9.
How many others? 68, 86. Do you put oh dang it. Do you put how do you do the whole like to get all of them? It's like B2 like
Oh, I just clicked OK or whatever it was to get the box to go away, and then it pops up in the same box that the mean was in.
oh.
It's just the same exact thing as you did to get the mean, only you click on the standard deviation function.
Yeah. Okay. Okay, what'd you get for it?
1.9.
Okay, that's what I got.
Okay. So 11, I created a histogram representing the amount spent in the cross-sell purchases. I don't know how to make a histogram. Do you know how to do that?
Um hold on, let me see. Freaking histogram. No. We never had to make a histogram.
I'm Googling it right now.
Oh, okay, hold on. Is that a histogram one again?
Isn't it like a bar graph, basically?
Yeah, why can't I find it though?
Yeah, I don't know how to do it either.
Let me see this. Nope. I don't know what I did. So hold on, I think I might have this. Hmm.
Yeah, I don't know how to do this. I don't remember ever trying to do this before.
Yeah. I don't even see. Uh, I don't know. We can come back to it. Let's just do that.
Okay. Alright, so moving on to 12. So 12 says, what is the value of the number that goes into position marked with an A in the above table?
Okay.
And I did this one earlier in the homework, I think. But I didn't label it. It looks like it's just the mean minus, or that value minus the mean, whatever it is. Let's see where I set my phone. I can get my calculator.
Hold on. Hello? I do not. Okay. Yeah. I'm in a math meeting right now, so I'll do it after. Okay, cool. Get back. Okay. Sorry.
No, that's okay.
Question marked A. So basically, ouch.
Oh, so we just have to figure out the mean of all of those.
Yeah, so it would just be 3 point and then 37.91 minus it's
Alright, hold on. I need to find my phone real quick.
that's cool.
Okay, got it.
What the heck?
Okay, so we just need to add up all of the numbers under x and then divide them by 4.
So got 38.075.
Yep.
Okay, and then we subtract that then from
We
the
subtract that from 37.91.
37.9.
Yeah. Which is 0.165.
Yep.
Or negative 0.165. And then what is the value of the number that goes in the position marked with a B in the above table? So we just have to do 37.25 minus 38.075, and then we find the square of that.
So would it be 0.027?
I got 0.608 or
Okay, hold
680.
on. Maybe. Oh wait. Okay, hold on. I did it wrong. That's my bad. Minus. Okay, hold on. I'm doing something wrong.
You take the value minus the mean, get the answer for that, and then get the square of that.
Okay, so that doesn't match this thing. That minus. Okay, so 0.868. How many decimals?
0.680.
Yeah. Well, it would be 0.681.
Would it be 1?
681. Yeah, because the next number is 6 after.
Okay.
At least for me. Are we doing it? Is it negative or are we in positives?
This one is positive, I think. 12 was negative, this one is positive. I don't think it really matters, though.
Really?
I don't know. Well, I put negative for 12, and this one I did not put negative.
Because, I mean, our number was 38 point something.
Mm-hmm.
And, I mean, obviously if we have the 37s in front minus the 38, we're going to be in the negatives. But if it's switched, then it'll be positives.
Mm-hmm.
So. Oh wait, but we square it, so it automatically goes to positive.
Yeah, so
Okay.
that way this one's positive.
Got it. Okay, so 14's what quantity is equal to the sum of the numbers in this squared division column? Are we still up in this top one? Yes.
Yeah. Wouldn't that, would it be the standard deviation?
Uh, I think so.
Because it's
I don't know
not.
if the standard deviation squared.
Well, what's the formula for standard deviation?
Am I putting it on here? Why can't I see it? Oh, okay, it's 0. Oh, sorry, not 0. Wait, no, that's wrong too. I don't know what I'm doing right now. Standard deviation is less than 3. Oh, there's a histogram stuff. Okay, hold on. It's the variance.
It's the variance. That's the answer.
I think.
Okay.
Well, it says the variance is the square of the standard deviation. So I think what we found was where I think up top is what we like the deviation from the mean. I think that is the standard deviation, and then squared deviation would be the variance.
No, well, it's not.
Does that make sense?
It's not the standard deviation because it's just the deviation for that particular set of data, if that makes sense. So it's showing the difference between that number and the other number, but it's not the standard deviation. It's just the normal deviation.
Okay.
So maybe it's none of these.
Here's the deviation, and yeah, maybe it's none.
Yeah, I think I'm going to go with none of them.
Okay. Okay, so what is the standard deviation of these temperatures? Great. So
I always forget what the formula is for the standard deviation.
standard deviation is the square root of 1 over n. Do we ever, I feel like we found standard deviation, but this is not what I used. So we're supposed to add all the numbers. Oh, so we're supposed to find the mean out of the numbers, so we did that. Mean was the 38 something. And then you what the crap? Maybe we can just put it inside the Excel chart.
Mm-hmm. Actually, not a bad idea.
I'm figuring. I mean, we used
Yeah, might as well.
because you're supposed to like do like a problem within each number.
Mm-hmm.
So that could take. Where's the So we got 37.91, 37.25, 38.98, 8.16. Two five.
I got 0.616.
I got 0.619. What'd you get?
I got 0.6159.
Okay, let me just make sure I got the numbers correct.
Let me make sure I got them correct too.
The next thing would be like,
Oh, I think I put one in wrong. I think I did
Okay.
37.26 and it's 37.25. Alright, let me try it again. Okay, I got 0.6. No, I got the same thing. I got 0.6159.
again? Isn't that what you had before?
It keeps changing my 37.26. It keeps changing it to 6 instead of 5. I don't know why. So I'm just going to go off your answer because I think you got it right.
Okay.
What did
Are
you
you
get?
doing the standard deviation point P? Like the
I
formula?
did. Um, Standard deviation P. Yeah, the first one.
Okay.
Okay,
Okay.
so what did you get for that?
I got 0.619.
Okay. Yeah. All right. So under certain conditions, the standard deviation can be negative. True or false? It would be. That's false, right? I don't know why how a standard deviation could be negative.
I don't know. I don't think it can. I don't think we've ever had a standard deviation that was negative.
Yeah. No, that doesn't really make sense.
I mean, we can have a Z that's negative.
Yeah, but standard deviation, I don't think you can.
Yeah. Okay. So 17.
Mhm.
In the study, the research placed thermistors, temperature sensors, and 3 seals named Chick, Starbuck, and Patty near their spinal cords and brain in the external vein. They placed thermistors in 6 other seals, so on, in the aorta, the largest artery in the body. Finally, they placed thermistors in 4 other seals in their hepatic sinus. The results of the study are summarized in the table below. Which location resulted in the most consistent temperature measurements from one seal to the other?
Looks like it would be extradural because it has the lowest standard deviation.
Hold on. Yeah. I think so.
Yep. Alright, 18 is I can define standard deviation in my own words. I'm just going to assume that's true for both of us. Yeah. Alright, and then 19, the number of hours students spent studying for an exam were recorded. The data are represented by the box plot below. Use this box plot to answer questions 19 and 20. 19, what is the third quartile? 8.
Yeah.
And then what percentage of data lies between 4 and 8 hours? Um,
4.
would it be 50% because it includes 2 of the quartiles?
Or would it be Trying to think, is it? Is
I would think so. I don't know what else it would be.
yeah, I think so. Okay, we'll go with that.
All right. Okay,
Would it
so oh, go
would it
ahead.
be 50 because I mean, is it the whole chart that they're listing now, or is it 4 to 8 is the whole thing pretty much, except for, I mean, are you going off the whole long chart line?
What do you mean?
Like, so 2 to 12, so that'd be like,
Well, yeah, that is what the data spans. That's the span of the data. We just need to figure out what percent is between 4 and 8, and since it shows that 4 to 6 is a quartile and 6 to 8 is a quartile, that leads me to believe that together they're 50% if each quartile is worth 25% of the data.
did it say it's worth 25?
I don't know why it wouldn't be if it's a quartile. It's divided up
Oh,
into 4.
true. Okay. For some
I
reason I was
mean,
thinking like, oh, it goes 2 to 12 or whatever, and so that would be 10, and then the 4 to 8 would be 4, so 10 to 4, that'd be like 40%, but I mean, you're probably right. I don't know.
I don't know. That just sounds
I don't
right.
know.
I don't know. I could be wrong. I don't know. But that seems most likely.
Yeah, no, that makes sense.
Okay, are we ready for the next one?
Yes.
All right. An observation from a normally distributed population is considered unusual if it is more than 2 standard deviations away from the mean. There are several contaminants that can harm a city's water supply. Nitrate concentrations above 10 parts per million are considered a health risk for infants less than 6 months of age. The city of Rexburg reports that the nitrate concentration in the city's drinking water supply is between 1.5 and 2.52 parts per million, and values outside of this range are unusual. We will assume 1.5 parts per million is the value of the equation is equal to 2.52 parts per million. It is reasonable to assume that the measured nitrate concentration is normally distributed. Estimate the mean of the measured nitrate concentration in Rexburg's drinking water.
So, so 10.
How do we figure this out?
Here, force 9 become 4, 9, 2, and its values outside the screen are unusual. U minus 2, 0. I don't.
Because I don't know how to figure that out.
Is it in a chart? Like, we're not given things to find the mean.
Yeah, I don't know how. I have no idea how that would happen.
So I'm like curious to see. What's that? What if the chart has it or something? But they would tell us if it had the
Yeah, if there
chart.
was a chart we needed, it would tell us.
What the heck did it go to? Yeah.
I figured out 22. 22 is 0.22 or 0.233.
How'd you find the standard
Well,
deviation?
I kind of cheated because I looked at 23, and it says between what two measured nitrate concentrations do approximately 68% of the data values lie, and that corresponds to standard deviation because the 68, 95, 90, whatever rule that talks about the amount of standard deviations. So each answer is a different set of standard deviations away. If that makes, I don't know if that makes sense, but I subtracted the first set from 1.59 and 2.52, and I got 0.233, so that makes it the standard deviation. I don't know if that made sense. I don't know how to explain it, but I'm pretty sure that's what it is.
Okay. So, do you think if we find if we put we could reverse that?
I don't. Maybe.
So, hold on. What is 22?
0.233.
0.233?
Yep.
Okay. So then that means 23 is C. Like the third one? Is that what you were saying?
23 is what?
Did you say that you said you were using 23, right?
Yeah, and I just used the first set of values, but for 23, I don't remember, is 68% one standard deviation away? Because if so, it would be A. It would be A.
The 1.357?
Yeah.
Okay. Yeah, it's one standard deviation. I mean, one thing.
Yeah, so then it would be A.
Okay, hold on. Let me see if there's a way to reverse.
I think, anyway, I don't know if that worked, but I was like, I don't know how else we're going to figure it out.
Yeah.
Do we want to skip that one for now?
Yeah.
Okay. Okay. 24 is, what is the mean of a standard normal distribution? Is it looking for a number or like a definition?
I wish, like, okay, hold on.
It can't be corresponding to a number because it doesn't have any data to go with it. Because the water stuff was just for
Yeah,
20.
it stops at 22, so, I mean, it has to be,
Would it just be the
what does it say,
average?
the mean?
Yeah, the mean is just the average.
The mean of the standard normal distribution. The standard norm has a mean of 0. It
Oh.
says the standard normal distribution has a mean of 0 and a standard deviation of 1.
Oh, okay. There we go.
There we go. So 0 and then the next one's 1.
Yep.
Okay. So go to 26. The administration committee for most Masters of Business Administration MBA program required the Graduate Management Admission Test (GMAT) as part of the application for new students. It has been shown that the score of the GMAT are normally distributed with a mean of 542.3 and a standard deviation of 120.54. The minimum GMAT score required for admission for the MACC program in the School of Accountants at BYU is 500, but it is rare for students with scores less than 600 to be admitted. What? Okay, so we got this is what we've been doing recently.
Yeah, so is this the one where we need the applet?
Yes.
Okay.
So I have that up already. So,
What lesson is the applet under again?
I mean, you can find it in the individual preparation,
Mm-hmm.
or I think it's in 7. I mean, I know it's in 5 for sure, but
Okay, got that up.
hold on. Let me get my computer charger. Okay.
So we need to find the z-score for 542.3.
Do we have the, like, how many people it's taking a test on? Right.
I don't think we need it.
Okay, so it's the value minus the mean divided by the standard deviation.
Divided by the standard deviation. But it's just 0 because this number they gave us is the same as the mean. So it's,
Well, would the value be different? Because, wait. What are you putting as your value?
it has to be 542.3 because that's what it's asking us.
Wouldn't that be the... Oh, okay. Okay. Okay, so yeah, it has to be 0.
But then our whole answer's messed up because 0 divided by anything is still 0.
Oh no, oh no, oh no. hold on. Oh, okay. Almost logged out. Well, when that, it'd just be, above 545. Well, wouldn't it be, you put it in the thing as 0 and put above, right? Because that's the question. Wouldn't it be 0.5?
Well,
I don't know. I just put it in short. I just put it in the applet.
I guess we might as well. I don't know what else we would do.
That's the only number we're getting.
Yeah. Okay. Point 5.
Yeah.
Okay.
I mean, it's the nearest tenth, so
Yeah.
that kind of would make sense, right?
Mhm. Yep. Okay. Yeah. Let's go with it.
Okay, so the next one we're changing it to 600.
Yeah. Is it the mean minus the value or the value minus the mean?
The value minus the mean.
Okay.
So 600 minus the 542. Then what's standard deviation again?
So for the z-score, I got 0.479.
Yes.
Okay, so the probability, it would be 0.316.
Yes. That's what I got. One second. 0.316.
Oh, but wait, that was below. So 0.316 is the answer to 28. And then I need to go back. Oh, but it would be the same thing for below, anyway. How does that work?
Well, are we supposed to shade one of the middles in one of them?
Probably for the below, we should shade the middle, yeah.
I think that's what you usually do, right?
Yeah, so it's 0.684.
Is it 648 or 684?
0.684.
Dang it.
What?
4 you said? I actually logged out of my chart.
Oh no. Yeah, it's 0.684.
Okay.
Then 28 is 0.316.
2.16. 316. Okay.
Alright, 29 says, find the GMAT score that corresponds to the 10th percentile. I don't remember how to do this.
Percentile. So it'd be in less than 3 again?
Let's see.
Medium mode.
I don't see where it says how to do this. Doesn't look like it's in lesson 3. Even though it says it is, it doesn't.
Percentiles and quartiles, is that what it is?
Yeah.
Well, it's talking about percentiles in lesson 3 at the very end in 6.1 of it.
Yeah.
How to find it is another thing.
Mm-hmm.
What score? Isn't this where we put it in and on the chart or something?
I have
And
no
we just
idea.
make it equal 90?
I don't know.
Hold on.
I feel like we're missing a set of data.
Find P90.
Would we use the normal probability applet and change the area to the percent that we want?
I think so.
I don't know how to do it.
What was the data? Do we even have data here?
That's what I'm wondering, is we don't have any data, so how are we supposed to do this?
Why is this so complicated?
I'm wondering if there's like a set. I'm gonna look and see if there's a set of data that we're missing. I don't think there is. This is really annoying. Yeah, I don't see how you can figure it out if you don't have all of the data.
I don't feel like these are like some of the questions that we really had to do before.
Yeah, I don't see how we can do this without, because it says we need to find the third quartile, first quartile, 10%. How do you do that if you don't have any of the data? That doesn't make any sense. Graduate management.
Did we ever get 27?
There's a couple yeah, 0.684.
0. Oh, okay. I shifted everything up a little bit. Okay. 684. Got it. And then 28 is 316.316.
What?
28.
0.316.
Okay. For some reason, I just put them in the 29 category. Answer I meant. Okay, so 10th percentile. I have no idea. What the heck?
I honestly don't know how we're supposed to answer that, and I'm looking through all these lessons, and I feel like we have not figured out how to do this without any data. Which is really annoying.
Yeah. Let's just move on, I guess. What the heck? Hold on. Question 25. This thing's all whacked out. Even the test is weird. Because this one says, like, we're supposed to use this information to answer 25 to 31, but we don't even start till 26. And it clearly goes past 31.
Brother, this is so annoying. I feel like this should be our test because it's so much longer than what we normally have to do.
Yeah. And we think this is long.
How long is the test going to be? That's what I'm wondering.
He said it's supposed to be 3 hours or so.
Oh my gosh. That's ridiculous. Test should not... Maybe if it was a midterm or a final, but if it's just like a normal test...
That's what he said, I thought. So...
I hope it doesn't.
Because why would he say, like, be there for 4 hours or have yourself available for 4 hours?
I don't know. Okay. Well, we've been working on this one for like an hour and a half almost.
Yeah. So let's see. Can we do any other problems?
Let's go down to 33. Consider a simple random sample of 15 students taking the GMAT. What is the mean distribution of sample mean scores for all such samples? What? My brain is fried on this right now.
I know what you mean.
Do we want to save this for later and do lesson 9 quiz?
I'm okay with that.
Okay. Because I don't want to deal with this right now.
Sounds good.
Alright, lesson 9.
Hold it up and pull it up. Okay.
Okay, so question 3. A hypothesis test consists of 2 hypotheses, the null hypothesis and the alternative. hypothesis. Which one represents the status quo? That would be the null hypothesis.
Yep.
Which hypothesis involves equality? Mm,
Oh, I think it's. Let me just confirm.
would it still be null because it just has the equals?
Yeah.
Yeah, I think it's just the null. Alright. 5. The p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. Use this information to answer question 5. When computing this probability, which hypothesis do you assume to be true? Wouldn't it be the null because that's like the status quo or the one that you would think would be true?
Yeah. Computer hypotheses seem to be true. Ouch. I mean, yeah. We're looking for the equal and whatever.
Alright, so 6, suppose the null hypothesis is that equation. Which of the following represents the alternative hypothesis for a two-tailed test? That would be the one with the crossed out equal sign.
Is it two-sided what? Two-tailed test?
Yeah, and two tails are the one when you have a dash.
It's crossed out. Left-tailed, so it would be the first one, right, for 7?
Yep.
And then right-tailed is the second one?
Yep.
Outcome of hypothesis. Okay, 9 is the outcome of hypothesis test is determined by comparing the p-value to the level of significance, or A. Use this information for questions 9 and 10. Which relationship would result in failing to reject the null hypothesis? So that is when I had it up right here. Isn't it when A is greater than P?
I don't remember. I'm trying to look.
Okay, so it says if the p-value is less than A, we reject the null hypothesis.
P-value.
Are we failing to reject? So then if the p-value is greater than A, we fail to reject the null hypothesis.
Okay, so that's the first one?
P is greater than A, yes.
So 10, it would be the second one, which is P is less than A?
Yes.
Alright. Oh, there's a lot of questions on this one, too. Alright, 11. An insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim amount was $1,500. They're concerned that the true mean is actually higher than this. Use this information for these questions. Which of the following would be an appropriate alternative hypothesis? It would be the average claim amount is greater than $1,500.
Okay, because it's saying how it's higher is they are concerned that the true mean is actually higher.
Yep.
Okay.
And 12, which of the following would be the appropriate null hypothesis? That would be the average claim amount is equal to
Equal.
1,500. Yeah.
Yep. So the first one. Okay, so 13 is the insurance company randomly selects n equals 40 claims and calculates the sample mean of x equals 1,650. Use this information for questions 13 to 15. 13. The insurance company assumes the distribution of the sample mean is normal. Is this a good assumption?
Does 40 qualify as a large number?
I think so.
Okay.
I think it is. Maybe. Do you think so?
I'm looking at it right now. Yeah. Yeah, it is.
Okay.
And then the law that justifies your answer, I think, is the central limit theorem.
Okay.
Alright, and 15, which of the following is the test statistic as defined in this lesson?
Which isn't it X
Yeah. Yeah,
no,
I
it's
think it's X.
Z,
Why would it be Z?
right? I don't know, I was looking at step 4. It says
Where?
give the test in step 4 of the lesson at the towards the bottom. And it says give the test statistic and its value. So would that be X I mean Z equals
Oh, I don't know. You think it's Z?
I mean test the statistic and its
Alright.
value. I mean I just
Yeah, I'm fine with that. Alright, 16.
yeah.
The historical. Are we good with that one?
What?
Are we good with Z?
For 15?
15. Mm-hmm.
We're doing S?
Z? Wait, why S?
Wait, no, I thought you said, like, the third one.
No?
Oh, okay, so... uh, so we're going with the second one.
Z.
Z. Okay.
Yeah. Alright.
Oh, goodness.
Okay. So 16. The historical mean of sales receipts at a grocery store is 150 with standard deviation of 40. The store manager suspects that the average has decreased. She sets up a hypothesis test with the following hypotheses. She will use a level of significance of 0.05. She then takes a simple random sample of 36 sales receipts from her store and computes x equals 144. What is the z-score associated with this test?
Mm.
So it would be 144 minus 150 divided by 40. I got 0.15.
I got negative 0.15.
Yeah, me too.
Okay.
All right. 17. What is the p-value associated with the z-score from the previous question?
Are we putting negative or are you keeping it plain?
I don't think it matters. I mean, I put a negative, but I don't think it matters.
Okay.
How do you find a p-value?
Um, going up. So p-value equals.
P-value is the area beyond the tails beyond the z-score in both the left and right tails of the standard normal distribution.
So do we just put our z-score in the chart?
Let me see. Well, let's start with that. So our z-score is 0.15. And then it just says that the p-value is the area beyond the tails in both the left and right tails of the standard normal distribution.
So we just do both sides?
What do you mean?
Like, shaded in?
I have no idea. Because on the example, there's nothing shaded in.
Or is it just so wide out we can't see it?
Are you looking at lesson 9 under 4.3.1?
Yeah.
Do you see that example?
Yeah. But you see
Yeah.
how far wide out it is? That, I mean, it could possibly not be seen? Even if they did shade it? Hold on. Go down a little bit to the other charts down on bottom from the lesson.
Which ones?
The 4.3.2.
Mm-hmm.
Do those have to do with us?
Um,
Like,
so you
would
think we
it be
should...
because we're equal and greater than? Would we be the left-tailed?
Hmm?
Would we be the left-tailed?
I don't think so.
Because, okay, you see how in our problem it says it's equal to 150, and then the other one is like less than 150,
Uh-huh.
and then this one on here is the same thing, like equal to 96 and then less than a 96.
Uh-huh.
Do you think that?
I mean, that chart is how a left-tailed chart would look, but I don't know what we're supposed to be doing with our chart, with our specific data.
Hmm.
And then, do you see the p-value charts underneath that?
Yeah. The large and the smaller, or whatever.
Yeah. Do you think that ours would be considered a large p-value? I say that our p-score is 0.881.
0.881. So we're going for both sides.
I think so.
Okay.
And then we would say that we failed to reject the null hypothesis. And then 19, there are two types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true? That's type 1.
Yep. So the research decided that instead of using a level of significance of A equals 0.05, he will use A equals 0.01, which of the following will be true. Says something about that in here. Other common choices, A equals. Come on, what the heck?
I think. Oh. It would be the probability of a type 2 error will increase.
Where'd you find that?
It says that if A is allowed to be very large, then the probability of committing a type 2 error will be very small. So if it gets bigger, the bigger the A number is, the more likely it is that, wait, okay, hold on, I might have done that wrong. It says if the A value, which is the probability of committing a type 1 error, is very small, the probability of committing a type 2 error will be large. So, since the number got smaller, the chance of a type 2 error gets bigger.
Will increase, okay.
Yeah. Okay, I read that right. So, 21, if A is equal to 0.05, compute the probability of committing a type 1 error.
So would that be 1 over 20? Because in the 4.5, it says the most common value of A is A equals 0.05. This is equal to 1 over 20. So would that be a probability?
Well, 0.05 just means 5%. So, wait, what was the question again? Probably, yeah, I think it would just be like 5%. 0.05.
Yeah, because I mean, that equals.
Yeah. Alright, did we skip any questions on this one?
Yeah. Wait, hold on. I don't think we did. I don't think on this one.
Okay, I'm going to go ahead and submit it.
Okay.
Yeah, 91%.
Sweet.
I'll take it.
What did we get wrong?
We got 16 and 17 wrong.
Not bad.
Yeah, oh well.
Still no.
Okay, so we still have to finish up group meeting from the other one.
Ugh.
I know.
Hours. I'm exhausted from that.
I know. It takes a lot out of you. So, alright, let's go back to the beginning and find the first question that we skipped. Oh, the histogram thing.
Yeah, hold on. Where is it? Okay, so the first one we skipped was 11. That was the histogram.
Yep.
So let's try to figure that out. I think lesson 3 has a chart of it, how to do it. I think lesson 3 has everything.
This is ridiculous. So we have to enter in the data on this quantitative descriptive statistics thing.
Yeah.
So then we have to open the crossroads page. It won't let me make any changes to the spreadsheet. Well, I can't do it if it won't let me enable editing.
This is okay. Hold on. Nothing on this chart. Can I just say true?
I'm cool with that.
Yeah, no. I can't even find where you can even place a histogram.
Yeah, you know what? I'll just say false for 11. I don't even care. I'm so done with this. Alright, so after 11, we skipped 21. There's a part of me that's really tempted to just put in random numbers for these last ones.
I'm like so over this.
I know, yeah.
Better things to do with my life. I hope he's not watching this video.
Well, I don't think he does
I
because
don't think he does.
he doesn't. Well, he just sent out that email saying he doesn't give credit to you unless you like tag your, like you comment on the video saying you're in it. So I don't think he even opens it. to like
Yeah, I had to
see
like
who's in it.
yeah, 'cause I got like the 0 on my 6 and 7
Mhm.
for our video. And so I like went back and like I like in all our videos I went back and was like I attended, I attended, I attended.
Mhm. Yeah.
I don't know if you can change that or something, but
Yeah. I don't know. I
even
think.
if I didn't get credit for it, even though I
Yeah.
was literally did it.
Yeah. That's ridiculous. So here's what I'm thinking. Since my brain is like really fried right now. So do you want to just, we can click save it for later, and then we can just go back and finish it individually when we're in a state of mind to finish it?
Yeah.
Are you cool with that?
Yeah, I'm
Okay.
totally cool with that.
All right.
'Cause I'm shot too.
Mhm.
And so I mean we only have like well um like 10 problems.
Mhm.
So
Yeah, yeah. I say we just leave it for now and just, oh well.
take your chances. Yep. That works.
Okay. All right. Yeah, we've been working on this for 2 hours. I think we've put our work in.
Yeah. Yeah. And just and we'll see if we even get a good grade for it. So
Yeah.
it's one of
All
those
right.
things where I'm like, I don't even care anymore. Like,
Yeah.
if I get a good grade, I just want it to be over with.
Mhm. Yeah. Agreed.
And we still have to take the exam,
Oh
and
my
I have to take that
gosh.
tonight, so I'm gonna be even more shot.
Oh man. Okay. Yeah.
So we'll do that and just figure it out on by ourselves. Then I'll be sure to add myself in the video.
Yeah. I'll put this up, and then yeah.
Yeah, I'll just check later. I mean, either today or tomorrow.
All right.
So you're fine.